Good evening. Can you hear me? Yeah. Good evening. Okay. Thank you. Okay. Let's start because we have a here bulk part to discuss today. Little bit advanced part, Kirchhoff second law, how to apply for complex circuits. Complex circuits. Last week, first of all, I will refresh you what we discussed last day. We discussed about Kirchhoff law and electromotive force. Okay, do you remember what's the definition of the electromotive force? Electromotive force, the the potential difference of any battery or any cell while no current is flowing. Okay, that's the simple meaning of electromotive force, the potential difference of any battery while no current is flowing. If it is, I told, if it is current flowing through any battery, due to internal resistance, what happened? Due to internal resistance, the voltage or potential difference getting less than the electromotive force due to the internal resistance. When current is flowing through these circuits or battery, what happened? Due to internal resistance and external resistance of the circuit, the voltage of the battery getting less than the electromotive force. Okay, that's the story. Finally, we discussed about what is the Kirchhoff first law and what is the Kirchhoff second law. Okay, what's the Kirchhoff first law? Do you remember? The Kirchhoff first law, he explained, the scientist explained about charge conservation. Charge conservation. If you got a junction of any circuit, junction එකක් ගත්තහම, think it's a junction. This is a junction. Okay, the flow, the flowing, the sum of flowing current like I1 and I2 both come into the junction, then it is the equal to the I3 leaving out from the junction. That means there is no any charge destroy or create. It is same as energy conservation, right? That's why we call the Kirchhoff first law. Kirchhoff first law we called as, it's explained about charge conservation. The Kirchhoff first law explained about charge conservation. What's the meaning of conservation? That cannot be create or destroy. Okay, that's a conservation. It's explained about charge conservation. Okay, let's go to Tute. They all we discussed. Now 70% of lesson completed. We discussed equal to resistance, more advanced calculation as well. Okay, Kirchhoff first law. The Kirchhoff, these are Kirchhoff first law. It's always explain the charge conservation or electric current conservation or charge conservation in a unit time. Charge conservation in a unit time or electric current conservation. Okay. Okay, can you remember what's the meaning of Kirchhoff's second law? Kirchhoff's second law. The Kirchhoff's second law is the net electromotive force or resultant electromotive force in a closed circuit loop. I already explained what's the meaning of closed circuit loop. That's the meaning of closed circuit loop. Closed circuit loop. If you got this type circuit, it has, I told this circuit has 1, 2, and with this outer loop, it has 3 overall loops. Number of 3 loops. First, second, and the full outer layer we can consider as closed loop. Okay, the net electromotive force, that means the IR multiplication, sorry, E multiplication, sigma E, the net electromotive force equal to the sum of potential drops in IR multiplications. IR multiplication, simple R and capital R. Simple R mean internal resistance, capital R mean external resistance, that's sigma. Okay, that's a sigma. Okay, that's the summary of Kirchhoff's second law. The IR multiplication, the sum of IR multiplication equal to, in complete loop or closed loop, inside a closed loop, the IR multiplication, the sum of IR multiplication equal to the sum of electromotive force. Okay, that's the Kirchhoff's second law. That's the Kirchhoff's second law that we already explained. We practice this type simple questions. Okay, I'm going to start with our homework questions. Okay, this one, no? Okay, this is a homework question. Did you complete? Can you send what is the current flowing through this circuit? Tanya? Others, only 2 answers. 0 point value? Yes, Tanya? Others, Dihini? What is the current? Fatima? What's the current? Very good. All are got same answer, no? Very good, very good, very good. Udanya, very good, Kabir. Fatima, Rehlan, Joel, what happened? What happened? Ah, Joel, correct, correct. Who else? Kabir, correct. Udanya, okay, let's try. Yeah, I think more than 6 answers. I have all same answer. And I have done very well last week. No? I'm happy. Okay. Okay. What is my first step? What's the first step? Label the circuit first. Okay. Label the circuit. I think this is A corner. B, C, D. Second step, mark the electromotive force directions. This is the electromotive force direction. Electromotive force directions. Electromotive force directions. Next, mark the current direction. What is the current direction? The current is any direction you can mark, no problem. That's up to you. I think the current is flowing into this direction, starting from this battery, starting from this 12-volt battery. I think this is the I, 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 and I. Okay, this is my current direction. Okay, I don't know. I got one direction. If you want, you can get other direction. No problem. No any issue. Okay. Now our circuit ready to apply Kirchhoff laws. Ready to apply Kirchhoff laws. Okay, I'll get more space for our calculation. Okay. What is the most suitable loop pattern to start our application? Okay, I'm going to apply A, B, C, D, A loop. A, B, C, D, A loop. Kirchhoff second law application. Kirchhoff second law application. Okay, what is my first step? First step. Mark, get the sum of electromotive force. Okay, I'm going to start A. This 10-volt opposite to my direction. 10-volt direction, 10-volt battery electromotive force direction opposite to my direction. I'm going to A to B. I'm going to A to B, but it is opposite to me. Therefore, it is minus 10. Minus 10. B to C, there is a battery. It is plus 12 because my direction and electromotive force direction same. C to D, opposite to my direction, therefore minus 4. D to A again. D to A. According to my loop, A, B, C, D, A. Then D to A. My direction opposite, it is -5. -5. Okay, this is the EM, the sum of EM forces or sum of electromotive forces. Rehlan, I think very small mistake. Okay, let's see. Okay, they are the sum of electromotive forces. Okay, now I'm going to again start A point. I'm going to again start from A point to get the IR multiplications. Okay, now IR, that means 1I. That's been I, no? My direction and current direction same, therefore minus n. My loop direction and current direction same, therefore all are plus values. All are plus value. I and 3I plus 3I, I plus 3I plus 2I plus I plus I again plus 2I again plus 2I. Okay, that's all. They are the IR multiplications. IR multiplication. What happened? IR multiplications. You can't see this corner. IR multiplications equal to electromotive force drops. Okay, -10, -4, -5. What's the answer? -19. -19 plus 12. What's the answer? -19 plus 12, -7. Good. -7 equal I plus 3I, 4I, 5, sorry, 4, 6, 7, 8, 10, 12. 12I. 12I. Okay. Now you can get the I -7 divided by 12. -7 divided by 12. Rehlan, what is the value? -7 divided by 12. It is minus 0.58. Minus 0.58. Why it is minus? Very good point. Why it is minus? Can anyone explain? Dihini, why it is answer minus? Current cannot be a minus value. Why it is minus now? I make a minus. Fatima? Can anyone explain? Any idea? Very good. I mark the current direction into this anti-clockwise direction. හරිද මේ left side එකට තමයි mark කරේ. According to this pattern, the answer was minus value. What's the meaning? The meaning, the current flow into opposite direction. That means clockwise direction. මෙහෙට තමයි current එක flow වෙන්නේ. That's the meaning. Okay, then you can say this is the answer. If you want, you can say it is 0.58 ampere flowing to opposite direction. Flow into opposite direction. flow into opposite direction. Okay, that's the final answer. 0.58 is the answer, ampere. 0.58 ampere flow into opposite directions of my assumed direction. Mark කරපු direction එකට නෙවෙයි rotate වෙන්නේ, flow වෙන්නේ into opposite direction. Okay, that's the story. Any doubt, Joel? Okay, next. I given homework on this paper, right? What's the question number? Here the question number. What's the question number? In this paper, I given homework, as I remember. Fatima, what's the question number? Yeah, third one we discussed. Then I think it is 7 one. Question number 7, right? 7 the dunne. Third one discussed as. Yeah, third one is a simple one. Rehlan? Seventh one. Good. Seventh one. Okay. What is the answer for question number 7? Three ohms, 2 ohms, 2 volts, 8 volts. Why for this circuit, battery has only voltage? What's the meaning? What's the meaning? Battery, no mention any internal resistance value. What's the meaning? What's the meaning? Udanne, what's the meaning? Normal previous questions. Previous question 12 volt, 2 ohm. But this question only to 8 volt. What's the meaning? No, always battery direct current supply. That's correct, Rehla. Now, what's the difference? I ask. What's the difference? Joel, what's the difference? The difference is battery don't have internal resistance. They are more power efficient batteries with long shelf life. That's the meaning of that's the electromotive force drop only by the external resistance. No any internal resistance. Now it is very simple. Okay, first I'm going to label this A, B, C, D. A, B, C, D. Then electromotive force directions I'm going to mark. Then the current always flow into 8, starting from 8 volt battery. Therefore, I'm going to mark in this direction. The direction change, I think now you got, if it is direction change, it's not an issue. Okay, finally by answer you can, yes, Rehlan, good. Finally by answer you can get the correct direction. Minus එකක් આવොත් the current flow into opposite direction, that you can find. Okay, I I I it is circulate like this. Okay, now I'm going to A B C D A. A B C D A loop, complete loop or closed loop. Okay, I'm going to A. My direction and EM force direction same, and no batteries and 8 volt. My direction same, 8 equal equal 3I, because my direction and current direction same, it is positive, and 2I. 10 equal 5I. I equal 2 ampere. It is very simple. That's very simple. Okay, that's all homework, right? Homework completed. Okay, let's move into bit advanced question with two loops. Two loops. Let's move into question number 5 on the paper. Question number 5 on the paper. Question number 5 on the paper. One ohm, 2 ohm, 1 ohm, 6 volt, and 1 ohm. Okay, very simple circuit. Simple circuit. Okay, this is 1 ohm. 1 ohm. Okay, it's a very simple circuit. Okay, what is my first step? Okay, please prepare this circuit for okay, for this now it is simple question. Now it is very simple circuit. with only uh, three parallel resistance and battery. Okay, now can you use Ohm's law? Ohm's law means V equal IR. V equal IR for this question. Can you use to calculate the area, to calculate the current? Can you use V equal IR? Okay, voltage okay, it's 6 volt. Voltage okay, but how to calculate there are two current. Okay, I'll explain. See, now think this is A, B, C, D, E, F. A is the circuit. Okay, now think the current direction. Think always current is flowing into this direction. This is I. Okay, what happened? This is a junction. Now you have to use Kirchhoff first law. What is the Kirchhoff first law? Kirchhoff first law. First law, in a junction, no any current charge loss. No any charge loss mean it's dividing into two paths. Then I can say this is I1, and if it is I1, what is this path current? I minus I1, the remain part. No, ඉතුරු ටික තමයි මේ කියන්නේ. I minus I1 is the current. This one I minus I1. I minus I1. Then I1 flowing through this upper path. I1. Again, I1 and I minus I1 combine and come to the same conductor. It is again I. Then I. Okay, they are the current. The problem, we can't use Ohm's law, V equal IR simple method. What's the problem? It has two currents. Current dividing. That's the problem. You can't use Ohm's law, V equal IR equation for this type simple circuits. For this type circuit, you can use. Okay, you don't need Kirchhoff law. මේ වගේ එකකට ඕනේ නැහැ. දැන් අපි හිතන්නේ මේ වගේ එකකට කියලා. Okay, this type circuit, you don't need Kirchhoff law because you can get the equivalent resistance and Ohm's law. You can use Ohm's law to calculate I. But if it is dividing, current dividing circuits, there are two batteries, more than one batteries like this. Now it is, you can't calculate by Ohm's law, you have to use Kirchhoff law. Are you good? Why we have to use the Kirchhoff law? Amina? What's the reason for we have to use Kirchhoff law? Tanya? Because current dividing circuits. Yes. For current dividing circuits, so more than one batteries on same circuits, we can't use Ohm's law. We have to use our Kirchhoff second combination of Kirchhoff first and second law. Okay, now we can't use V equal IR. Okay, now I'm going to mark what is the EM force direction. Okay, now tell me a complete loop, closed loop to identify Kirchhoff second law. Okay, you can suggest, I can write that. I can apply Kirchhoff law into your loop. Hari, one loop by A, B, C, D, E, F. I need complete loop. Joel, what's your suggestion? AFCBA. AFCBR. Good. Okay, I'm going to use Kirchhoff's second law into AFCBA loop. That's your suggestion. FCBA. Now, AFCBA. Then I'm going to AF C, no batteries. C to B, no batteries. Only one battery. It is my direction and EM force direction same. Therefore, it is 6 volt. It is positive. 6 volt. It is positive. Now equal to A to F, no resistance. 2I minus, my direction and current direction same. 2I minus I1. 2I minus I1 equal, not equal, plus, because my direction and current direction same, I mean 1I, that's 1 I mean I, again I, sorry, I. What happened? Okay, 6 volt equal 2 into I, 2I, 2 minus 2 into I1, 2I1, plus I, 2I. 2I plus 2I, it is 4I. 6 volt equal 4I minus 2I1. Okay, this is my first equation. 6 volt equal 4I minus 2I1. It is I1. Okay, tell me another loop on this circuit. Loop එකක් කිය. Another complete loop to apply Kirchhoff's second law. Dehini, tell me another loop. BAF EDCB. BAF EDCB. Good. That's okay. ABD AE. ABD AE. ABD EA. ABD EA. Good. Now, if can I use the upper loop FCDEF? FCDEF, Joel, can I use it? පුළුවන්ද මට use කරන්න? Tanya, can I use FCDEF loop? No, very good. What is the reason? It don't have batteries. Without batteries, how to get the sum of electromotive force? Okay, you can't use. Okay, then I have one option. AB DAE. AB. No, better to get in this direction, into current direction. AEDBA. AEDBA. Loop. Okay. Only one battery. Therefore, it is 6. volt equal AE no resistance. Sorry, it is I1. I1. Okay. It is I1. 1 into I1, it is I1. No resistance. Plus my direction and current direction same, plus I again plus I. Okay, it's simple. Now 6 volt equal I1 plus 2I. I1 plus 2I. This is my second equation. Okay, now I have two equations. Okay, I want to solve this equation now. What I can do? I want to solve this equation now. Okay, now you have two simultaneous equation. I'm going to get this both equation into next page for clearly explain about simultaneous equation. Okay, my first equation was 6 volt on a 6 equal 4I minus 2I1. 4I minus 2I1. This is my first equation. My second equation, 6 equal I1 minus 2I. 6 equal I1 minus 2I. Okay, now I have two equations. What is my target? I want to calculate and what is the I1 value? What is the I value and I1 value? Okay, first of all, my first requirement, I want to equalize one coefficient. Now, I coefficient I want to equal. Therefore, second equation I can multiply by 2. Then it is 12 equal 2I1 minus 4I. Now this is my third equation. Now you can see I coefficient of both equations same. Okay, now it is 4I. It is minus 4I. Plus and minus, no. If it is plus and minus, always your requirement, always these two equations, you have to add these two equations. Okay, clearly understand this simultaneous equation. I told homework, as a homework you have to refer about them. Okay, now two coefficient is equal, but the sign is different. It is plus, it is negative. Okay, therefore you can add your first equation into third equation. That's a method. Add. Okay, 6 plus 12. 6 plus 12. 6 plus 12 equal 4I minus 2I1 plus add 2I1 minus 4I. Okay. Now you can understand plus 4I1, plus 4I1 cancelled into minus 4I. 6 plus 12, it is 18. Minus 2I. Yeah, for this question, again cancel out. That means both values 1. Yes. For I, yeah, the the problem of this equation, both cancel out. Minus I1 plus 2I1 cancel out. Wait. Yes, minus 2I1. Sorry, it is plus, my mistake. It is plus. Wait, I will correct it. This is minus, this one plus. Yeah, first equation minus, second equation plus. That's why my mistake. If it is plus, that one also plus, right? Yeah, that's a mistake. That's a mistake. Okay, sorry, I'll correct it. It is plus now. Okay, now both coefficients same sign, same plus plus. And but 2I1 and I1 both coefficient 2, but it is plus and negative. We can add now. We can add first equation. I am going to add into third equation. 6 plus 12 equal 4I minus 2I1 plus 2I1 plus 4I. 6 plus 12, 18 equal minus 2I1 to plus 2I cancel out. 4I plus 4I, it is 8I. Then I equal 18 over 8. Can you send your answer? 18 over 8, 2.12. Okay, the simultaneous equation you have to practice. Okay, you have to practice it. I think you got the method. මට මෙතන මේ එකක් දාලා නැති නිසා පැටළුනේ. හරිද? මම next one I will explain it. They are very simple. 2.25. 2.25 ampere. Okay, if you got, it is I value. If you know I value, you can isolate this 2.25 ampere into any equation. Now you have three equation. Okay, now I equal 2.25 ampere, substitute into first equation. First equation, it's easy. Okay, now let's check 6 equal 4 into I equal 2.25 minus 2I1. 6 equal 4 into 2, it is 8. 0.25 into 4, 1. It is 9, right? 9 minus 2I1. Now minus, sorry, 9 get into left side direction, it is minus 3. Minus 3 equal to minus 2i. Minus to minus cancel out. I equal, sorry, I1, sorry, I1 equal 3 over 2, it is 1.5 ampere. Okay, I1 equal 1.5 ampere. I equal 2.25 ampere. Understood? Okay, clearly note down. Okay, that means I equal, I value was, the I current was 2.25 ampere. The I1 current was I1 1.5 ampere. 1.5 ampere. Then in this middle path, I minus I1, I minus I1. What is this value? I minus I1 mean 0.75. 0.75 ampere. Okay, that's how the current is flowing through this circuit. If you have any doubt, please ask now, then I better to easy to understand in the basic level. Rehlan, Sarmya, Dihini, understood? Sarmya, understood? Oh, Samia, you have to watch again then. Okay, let's try to understand from next one. Why you was late? Rehlan, okay? The simultaneous equation, it's not electricity, okay? It's all level maths. Make a methanidam part all level maths. Up to this level, we got electricity. Okay, question number circuit paper question number 3, not 3, 4. Question number 4. Make a better to draw this on your book or your tutor or any paper on your working paper. Okay, this is a circuit. Okay, second step, label the circuit A, B, C, D, E, F now. Any order you can use. It's not no any tough rules this case, these calculations. Everything up to you. If you use any order, if you use any direction, current direction, the answer same. You can try again these questions, same question you can try again for another directions. You can try, same answer come. Okay, what's my next step? Mark the current direction. I think this is the current direction, I, because 6 volt. No, current direction given, no? Okay, let's mark the current direction according to the given in the circuit, according to the given pattern of the circuit. This is I1. Same method. I1, I1. And I2. I2 coming from this section, I2. I2, then this one, I1 plus I2. That's okay according to Kirchhoff first law. Incoming two sections, I1 and I2. එතකොට මේකේ අනිවාර්යෙන් I1 plus I2 වෙන්න ඕන. I1 plus I2. That's the current. I1 plus I2. I1 plus I2. Again I1 මෙතනත් I1 plus I2. It is I2 flowing this path. Again I1 flowing from this one. I1, I1. Okay, they are the current directions. Okay, now tell me what is the better loop we can use? Complete loop. Loop එකක් කියන්න බා. Fatima, suggest a loop. A, B, C, F, A. A, B, C, F, A. Yeah, that's okay, but A, B, C, F, A, okay. No. A, B, C, F, A. I'm going to apply Kirchhoff's second law into A, B, C, F, A. A, B, C, F, A loop. A, B, C, F, A loop. Okay, what are the steps? First, you have to mark electromotive force direction on your battery. They are the electromotive force directions. Okay, now everything ready for the Kirchhoff's second law. Now I am going to apply Kirchhoff's second law into this lower loop. A, B, C, F, A. Okay, step number 1, electromotive force. AB, electromotive force, my direction and electromotive force direction, this arrow direction opposite. Therefore, it is minus 6. Minus 6. My direction and opposite. Arrow direction. Now A to B, okay, no any battery. B to C, no any other battery. But C to F, there is battery. But my direction and arrow direction same. Therefore, plus 3. Plus 3. Plus 3. That is a summation of electromotive force that is equal to the net electromotive force equal to the IR multiplication. 2I1, sorry, my direction and current direction now opposite. Therefore, minus 2I. Minus 2I1. Again, minus 2I1. My direction and current direction on this middle section, it is same. Therefore, plus I2 plus I2, 1 I2, that means 1, no any other resistance. Okay, minus 6 plus 3, it is minus 3. Minus 3 equal minus 2I, minus 2I, it is minus 4I, I1 plus I2. This is my first equation. This is the first equation. Okay, tell me another loop we can use. What's the next one? Another loop. Habir. Another loop. AEB, sorry, AEDBA. AEDBA. That means outer path, no? Can't you use FCEDF? Sorry, FCDEF? Rehlan? Can we use F, C, D, E, F? Yes or no? Yes, we can. Both we can. But our requirement only two. Then අපිට දන්නේ නැති currents දෙකයින් තියෙන්නේ I1 and I2. Therefore, my requirement only two equations. Therefore, two දෙකක් ගත්ත නම් ඇති. හරිද? Now I am going to apply Kirchhoff's second law into what's you say me AED 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 BA. Yes, BA. Loop. Let me complete one. The full loop, full circuit. Okay, I'm going to start A, no resistance A to E. Sorry, no, not resistance. First of all, I'm looking about batteries. No batteries, no batteries, no batteries. It has only one battery, my direction and electromotive force direction same. Then it is 6 volt. 6 volt. 6 volt. Okay, I'm going to start again A to E, no resistance. There is 1 ohm resistance, therefore I1 plus I2. I1 plus I2. No other resistance. It's 2I1. My direction and current direction same, therefore it is positive. 2I1. Again 2I1 plus 2I1. 6 equal I1, 5. 5I1 plus I2. This is my second equation. This is the second equation. Okay, now I have two equations. Using simultaneous equation solution method, you can get the I1 value and I2 value. I1 value and I2 value. Okay, I'm going to write my two equation in this page. Minus 3 equal minus 4I1 minus 4I1 plus I2. This is my first equation. What is my second equation? 6 equal 5I1 plus I2. My second equation. Okay. Oh, sorry. My second equation. Okay, next. Now you can see I2 both coefficient same, right? I2 both coefficient 1. Then I can use I can subtract first equation from second equation because coefficient are same and both positive. That's why subtract. If it is positive and negative in different signs, we can add. That's a method. හරිද? අපි මේක කරන්න ඕනේ coefficient දෙකක් equal කරගන්න ඕන. I1 එකේ හරි I2 එකේ හරි coefficient දෙකක් equal කරගන්න ඕනේ. Equal කරගෙන ඒ දෙන්න if it is different signs, different positive and negative, we can add. If it is same sign, we have to subtract. That's all. That's all simultaneous equation. Okay, now 2 minus 1, then 6 minus 3. 6 minus 3 equal 2 minus 1, therefore 5I1 plus I2 minus, brackets very important for subtractions, brackets very important, minus 4i I1 plus I2. Okay, minus, sorry, 6 minus 3, it is 9. 5i1 plus I2 minus it is plus, minus into minus plus 4i1 plus minus it is minus I2. Okay, now what happened? Plus I2 to minus I2 cancel out. Plus I2 to minus I2 cancel out. 9 equal 5i1 plus 4i1, 9i1. Okay, 99 cancel out. I1 equal 1 ampere. I1 equal 1 ampere. I1 equal 1 ampere. If it is I1 1, I1 equal 1, I1 I1 equal 1 ampere, substitute to the first equation. Substitute to first equation. Then you can get, or second equation easy because no minus value, second equation. 6 equal 5 into I1, it is 1 plus I2. 5 into, yeah, that one also 1 ampere. No? 5 into 1, it is 1. Sorry, 5. 5 subtract, then it is 1 ampere. I2 also 1 ampere. It's a special case. I2 also 1 ampere. I2 also 1 ampere. I2 1 ampere. Then we can say I1 equal 1 ampere. I2 equal 1 ampere. But I1 plus I2, the above part current flowing 2 ampere. Okay, that's a summary. If you have any doubt, please ask. Sarmia, how about now? Okay. Complete. If you complete, send message. Okay. Danya, understood? Okay. Let's move into another question. The paper complete, no? The paper complete. Yes. All questions. Sorry. Question number 5 discussed. Question number 6, very simple. Question number 6, homework. Okay, question number 6, homework. I will give you another question. It will be advanced. 5 and 4 discussed. 6, homework. Okay. Okay, this is the circuit. Okay, this is your chance. Okay, I will mark all data. You have to calculate. You have to calculate what is the current flowing through this circuit. Okay, they are the EM force directions, and A, B, C, D, E, F. Okay, this is a current direction. Okay, current start from this end. I. This path I1. I1 flowing through this path I1. Then if it is I1, what is the remain? I minus I1, I minus I1, I minus I1. Clearly note down the current I minus I1, I minus I1, I minus I1. And again, the I current flowing to through this part. Okay, this is the circuit and current directions. Okay, please mark this data on your uh, book. I can give you 5 minutes. You have to calculate what is the value of I and what is the value of I1. Okay, get 4 minutes. Try to complete within 4 minutes. I1 plus I2. Yeah, if you want, you can get like this. ඒක මාක් කරන විදිය අනුව ජෝ. Okay, complete. Now time enough. Anyone? Could you get the answer? Could you get the answer? Dihini complete. Fatima. What is the I? What is I1? Okay. Others? Only two. Okay. Let's start. Okay, if you complete, you can send me answers. Okay, I'm going to start. Okay, I'm going to first apply Kirchhoff's second law into left side loop. B A F E B. B A F E B loop. How about 12 volt? It is positive because my direction and 12 volt. No any other battery, therefore it is equal to 2I, my direction and current direction same. 2I 3I plus 3I plus 2I1. Okay. Now 12 equal 2I plus 3I 5I plus 2I1. This is my first equation. Okay, next you have to get another equation. You have two options. You can get this A, C, D, F, a full circuit, and if you get right side part, I am going to use right side part. What is the right side? EDCBE. EDCBE loop. EDCBE loop. only one battery, it is equal to my direction, therefore it is 6 volts. 6 equal to 4i minus i1. 4i minus i1. Again 2i minus i1 plus, because my direction, and 2i minus i1. BE part, my direction and current direction opposite, therefore 2 minus 2i1. You have to very careful, okay, when you use these plus minus values. Okay, then 6 equal 4i1, sorry, 4i minus 4i 1 plus 2i minus 2i1 minus 2i1. Okay, 6 equal 4i plus 2i, it is 6i. 6i minus 4i1 minus 2i1 minus 2i1 minus 8i. Okay, this is my two equations. Those are my two equations. 6 equals 6i minus 8i1 and 12 equal 5i plus 2i1. Okay, I'm going to put these two equations into next page. First equation, six I1 minus 8I1. This is my second equation. Okay, now I1, it is minus 8. This one plus 2. Okay, if I can multiply my first equation by 4, then I can equal the coefficient of I1, right? Equal the coefficient of I1. Equal the coefficient of I1. Okay, how to equal the coefficient of I1? 12 into 4, it is 48, equal 5i plus, not 5i, 20i. 20i plus 8i1. Okay, this is my third equation. Third equation. Okay, now you can see 8 and 8, second equation and third equation, I1 coefficient same and signs are different. Then second equation add into third equation. 6 plus 48 equal 6i minus 8i1 plus 20i plus 8i1. Now minus 8i1 to plus 8i1 cancel out. 48 plus 6, 54. 54 equal 6i plus 20i, 26i. Okay, can you send the value of I? 54 divided by 26? 54 divided by 26? 56. 54 divided by 26? 2.07. Good. 2.07 ampere. Okay, this is the I answer. Okay, now if it is I 2.07, I can isolate, I can substitute I equals 0 point, sorry, no, 2.07. I equal 2.07 ampere, substitute it into any equation. I can substitute into first equation. What's my equation? 12 equal 5 into 2.07 because it is I plus 2I1. 12 equal 5 into 2.07. What is the value? It's 10 point value. 10.35. 10.35 plus 2I1. Okay, 10.35 get into left side. It is 12 minus 10.35. 12 minus 10.35. It is 1.65. 1.65 equal to 2I1. Then I1 equal 1.65 divided by 2. 0.825 ampere. 0.825 ampere. Very good. Joel correct. Tanya correct. Dihini, are you correct? If you got any loop, then අපි ගත්තේ මොනවද left side and right side loops. If anyone got left side loop and the complete loop, the full one, the same answer, no any difference, no any change. Fatima correct? Abir? Sarmia? One correct, one wrong me? Fatima? I correct. If it is correct, the second one only substitution. I think calculation error. Rehlan, what happened? Okay, let's move into final question. Okay, this is a final question of Kirchhoff law. After that, I am going to give you homework, and next week I'm going to start our magnetic fields, and final day. Yeah, how many weeks for this month? Yeah, today 4th, Independence Day. Okay, 18th of February we can complete electricity, and after that I hope to start very important lesson, maths lesson, statistics. After statistics we can discuss our uh, natural products. Natural products only 3 weeks, 3 days, uh, industrial chemistry. Yes, cell structure. We only discussed biomolecules. We have cell structure lesson. It's a bulk lesson. Okay, that's a the time is very important now. We have to get extra classes as well from March next month. Extra classes mean we have to get theory discussion in our revision classes as. If we continue theory all times, all our 3 days, then within March we can complete at least 80%. We can complete. Then we can continue as our regular pattern, revision question and theory class, our basic normal lesson. Okay, let's see. We have 1, 2, 3, 4, 5 theory lessons, theory based lessons. uh, Cell structure, full theory, natural products, environment chemistry, industrial chemistry, and polymers. They are theory based lessons. After that we have physics lesson, fluid mechanism, physics lesson. After that we have uh, fluid mechanism තියෙනවා. ඊළඟට next statistics. Statistics is a maths lesson. That's all. We have only 7 lessons. Normally, polymers we can discuss within 1 day. No, ICT lessons are very simple. Within 1 to 2 days, we can complete everything. You want to complete first physics, chemistry lessons. During practical classes, we can complete ICT lessons. With practicals, we can complete Excel, Word, PowerPoint, a basic office package, and emails, internet, web address. They are very basic things like O-level ICT. This Excel part, Excel equation and formulas, very important. They are always asking in 2 to 3 questions coming in exam. Excel part. I think Word part, PowerPoint part, you can manage. If you use laptop or any computer, you can, in general knowledge, you can understand these questions. Okay, let's go to our final question. Okay, this is the question. Okay, draw this circuit and calculate the current flowing through this path. Okay, I'll help you. They are the EM force directions. Okay, this is the current direction. Current starting from this path, I, I, I2 coming from this direction, I2, or I1, 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 I1 plus I2, I1 plus I2 flowing through this path. Again, I1 plus I2 plus I1 making only I, not I1, I. Okay, that's the current. I want to calculate what is the value of I and what is the value of I1. Okay, can start now. Not three unknown factors. Mistake. Only two. Wait. No, it's mistake, no? Wait, I1. Yeah, I plus I1. Sorry. I plus I1. මේ දෙක එකතු වෙන්නේ. I1 plus I. I1 plus I. Now okay, right? I1 මෙහෙන් යනවා. Then I1 plus I. Now okay? Okay. Still calculating? Okay, let's try to get this. Okay, I'm going to apply Kirchhoff's second law. You have to label this now. You have to label A, B, C, D, E, F. I'm going to use A, B, C, F, A. A, B, C, F, A loop. Minus 12 minus 6 equal I plus I1 plus I plus I1 3I plus I1 4 I1 2I plus I1. Okay, it's a very long one, right? Minus 18 equal to I plus 2I1 plus I1 plus I plus 3I 3I plus 3I1 plus 4I1 plus 2I plus 2I1. It's very long one. Now minus 18 equal to then බලන්න I ඒව 2 ඔල්ල plus 2 3 6 8 8I plus 2 3 6 10 12 12I1. Okay, this is my first equation. Next, I'm going to apply Kirchhoff's second law into my above part. CDEFC. CDEFC loop. CD. It is only one battery. CDEFC, it is plus 18. 18 equal CD 1I, that's mean I, plus 2I plus 2I minus 4I1 minus 4I1 because my direction and current direction opposite. Okay, 18 equal, it's the short form, 18 equal 3I 6, sorry, 5I minus 4I1. This is the second equation. Now you can solve this two simultaneous equation. Minus 18 equal 18 equal okay, this is my first equation, second equation. Now in coefficient same now. Okay, better to multiply our second equation by 3 to convert into minus 12. Convert into minus 12. 18 into 3. What's the value? 18 into 3? 18 into 3. 54. 54 equal 15 minus 12i1. This is my third equation. Okay, now we have three equations. I am going to add first equation plus third equation. Minus 18 plus 54 equal 8i plus 12i1 plus 15i minus 12i1. Okay, plus 12i1 to minus 12i1 cancel out. Minus 18 plus 54, it is 36, no? Plus 36. Am I correct? 54 minus 18. Correct, right? 54 minus 18. Yes, 36. 8i plus 15i, 23i. Then I equal 36 over 23. .56 approximately. Anyone got this answer? Joel? I value 1.5 hour. Good. Now 1.56 I am going to substitute into any equation. Better to substitute in second equation. Yeah, 7.8. You have to practice again those same questions. Then 18 minus 7.8. 10.2. 10.2 equal minus 4i1. Then i1 equal 2.55, but it is minus 2.55. Okay, who got these both answers? How the හරියටම ගත්තා? Raise hand. Tanya, correct? Joel, correct? Very good. Dihini got Fatima. Habib, correct. Habib. Oh, what's the mistake? Calculation error. Okay, that's the problem. Okay, please note down. Then you can try again. Try again. If you have answer, you can try. You have to practice again and again. I think you have idea now. You have full idea, Kirchhoff flow and simultaneous equation, but calculation error, this type of complex equations, the calculation, the perfect calculation, very important. Calculation actually, you don't coming calculation errors because you have calculators. You can use calculators. Please use them to avoid calculation errors. Okay, then I equal 1.56. I equal 1.56. I equal 1.56. But I1 is not flow into this direction. I1 flow into right side direction because it is minus value. Okay, then you have to say I equal 1.56. I equal 1.56. That's okay. Ampere. I1 equal 2.55. 2.55 ampere into opposite direction. Into opposite direction. Not our mark direction. එයා යන්නේ මේ පැත්තට. Understood? Okay, that's a final summary of the lesson. Fatima, error? What happened? Wrong. Yeah, please take a screenshot and note down again, and you can try again. That's not too difficult. Actually easy, no. මේ තරම් ලොකු questions එන්නෙත් නෑ exam එකේදී. Simple questions asking, but for practice I got these complex questions. Okay, that's maximum. Okay, practice, and you have homework in Tute. Very simple homework. Question number 6. Question number 6 for homework. You can practice. Question number 6 for homework. And please go through these same questions again, and please compare with my answers and your answer after. Try yourself. Okay. Okay, then I'm going to complete Kirchhoff laws, and let's meet next week with magnetic fields, our next part of the electricity lesson. And you can try. I have given a lot of paper in our final tute pack. Yeah, මේ ටික තියෙනව නේද ඔයාලට? Yes, now you can try those questions. Okay, අපි දැන් ගොඩක් කරලා තියෙන්නේ. You can try these questions. Completed part, you can try for completed parts. And please work on this lesson, otherwise it's little bit difficult, this lesson. You have to work a lot. You have to work hard for this electricity lesson actually. That's why I given a lot of questions. I think more than 1,000 questions there. Okay, then let's meet next Friday with final part of our exam. Goodbye. Good night.